Alright, so we keep doing exercises about introduction to logarithms. So as we learned before, log base a of b is going to be equal to x when a to the power of x is equal to b. Okay, so in this case, if the base is a, then in this equation the base is going to be a. Alright, so what we are doing is so simple. A to the power of x is going to be equal to b. Alright, so let's start with this example. Let me write an example here. Let's say log base 4 of 2x plus 6 is equal to 3. Then the question here is the value of x. The value of x is the question. Alright, so the first step, we need to find the value of this expression right over here. Okay, so that's going to be 4 to the power of 3. 4 to the power of 3. So 2x plus 6 is 4 to the power of 3. So let's find 4 to the power of 3 here. 4 to the power of 3 is 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So 2x plus 6 is equal to 64. So in order to find x right over here, first of all, I need to get rid of this positive 6. And then I'm going to get rid of 2, so that I am going to be having x on the left alone. So now let's say that this is equal to 64. Okay, so now I am subtracting 6 from both sides. Subtract 6 from both sides. So I will be having 2x on the left, because positive 6 minus 6 will be 0. So 64 minus 6 is going to be 58. And now I can divide both sides by 2. Alright, so dividing both sides by 2, I'll get here 2 and 2 cancels out. So I will be getting x equals 58 divided by 2, 29. So in this equation, x is equal to 29. Alright, so I'm going to be solving this example now. So you can pause the video and give it a go first, and then you can check your answer. So once again, 5 to the power of this expression will give us this expression right over here. Okay, so 5 to the power of 3x plus 2 is going to be equal to whatever the expression is. So that's 25 times 5 to the power of x plus 6. Okay, so as you can see, the base right over here is 5 and the base is here 5. So just let's think about if I can write 25 in the form of 5 to the power of something. So when you just prime factorize 25, you're going to get 5 times 5. So 25 is actually 5 times 5, which is 5 to the power of 2. So 5 to the power of 3x plus 2 is equal to, so I'm going to be replacing 25 with 5 to the power of 2 and times 5 to the power of x plus 6. So here now we are multiplying two exponents, right? So we have the same basis. I have 5 to the power of 2 and I have 5 to the power of x plus 6. So for example, when we have 5 to the power of x times 5 to the power of y, or actually let me just change it. When I have the same basis, like a to the power of x times a to the power of y, then the result is going to be a to the power of x plus y. So that means 5 to the power of 3x plus 2 is going to be equal to So now we add these powers, these exponents. So x plus 6 plus 2. 5 to the power of, or we can write 2 plus x plus 6. So 2 plus x plus 6 is going to be equal to x plus 8. So 5 to the power of 3x plus 2 is going to be 5 to the power of x plus 8. So in this equation, we have the same basis. As you can see, I have 5 and 5 here. So the powers, the exponents, must be the same. So I'm going to continue my solution right over here. Okay. So I'm going to use this space to continue the solution. So if the bases are the same, the powers must be the same. So 3x plus 2 is going to be equal to x plus 8. So now, in order to get x here, so I can move this positive x to the left, or I can subtract x from both sides. So let's actually leave a space here. So x plus 8. And let's subtract x from both sides. So minus x and minus x. So on the left hand side, I'm going to have 3x minus x, which is 2x. And I have plus 2 is equal to. So x minus x is going to be 0. So I'll have only 8. And then now I can just subtract 2 from both sides, because I want to leave 2x alone here. So I'm going to subtract 2 from both sides. So let me just leave a space here. And then let's subtract 2 from both sides. So minus 2 and minus 2. So that way I'm getting 2x is equal to 8 minus 2 is 6. And if you just divide both sides by 2, then 2 and 2 will be cancelled out. Alright, so 2 and 2 will be cancelled out. So I will have, so x is going to be 6 divided by 2, 3. So this is going to be the answer. So when you just replace x with 3 right over here in this case, so this equation will be satisfied. Alright, so x is 3 in this case. Now let's do another example. Okay, so this is the next example that we're going to do. Once again, you can just pause the video and give it a go. Alright, so we have log base 5 of x squared plus 3x plus 15 is equal to 2. So this expression in the brackets is going to be equal to 5 to the power of 2. So x squared plus 3x plus 15 is equal to 5 to the power of 2. So x squared plus 3x plus 15 is going to be 5 to the power of 2 is 5 times 5, which is 25. And I can subtract 25 from both sides. So when I just subtract 25 from both sides, I'm going to get x squared plus 3x plus 15 minus 25 is going to be 0. Okay? Because here, like I'm going to subtract 25 from this side and also from this side, right? So this is not a power. Be careful. I'm just subtracting, okay? Alright, so I will get 15 minus 25 is going to be negative 10. So I will get x squared plus 3x minus 10 is going to be equal to 0. Alright, so after this step, you can just factorize this expression, this quadratic expression, and then you can find the roots of this quadratic equation. Or we have actually this rule for quadratic equations. If we have a quadratic equation in the form of a x squared plus bx plus c is equal to 0, then the sum of the roots, that means the sum of all possible values of x is going to be let me write here the sum of the roots, the solutions, the roots, is going to be negative b over a. Okay? So here in this case, b is positive 3 and a is 1. Okay? b is positive 3 and a is, so if there's nothing in front of x squared, as you can see, the coefficient of x squared is going to be actually positive 1. So negative b is going to be negative 3 because b is positive 3. So in this case, let's write the sum of all possible x values, all x values, is just going to be equal to negative 3 divided by positive 1, which is negative divided by positive is negative. 3 divided by 1 is 3. So this is going to be the answer. Right now, let's look at this example. So once again, please try yourself first and then check your answer. So here in this case, we have in brackets another logarithmic function, log base 2 of x. But we are just using the same rule. 3 to the power of 1 is going to be equal to this expression. Okay? So we know that log base a of b is equal to x when a to the power of x is equal to b. A to the power of x is equal to b. So in this case, a is equal to 3, b is equal to log base 2 of x, and x is equal to 1. Okay? I mean, do not confuse this x and this x right over here. Just be careful. So, alright, so let's just start solving this example. We're going to find the value of x. So 3 to the power of 1 is going to be equal to this expression. So log base 2 of x is going to be equal to 3 to the power of 1. And any number to the power of 1 is going to be that number itself. So 3 to the power of 1 is going to be equal to 3. So log base 2 of x is going to be 3. So now, in order to solve this, we need to take 2 to the power of 3 to get x. So 2 cubed is equal to x. So that means x is equal to 8. So this is going to be the answer. So this is a similar example. We will be using the same idea. So here, this expression in the brackets is going to be equal to 3 to the power of 0. You see, 3 to the power of 0 is going to be equal to this expression. So log base 7 of 5x minus 3 is going to be equal to 3 to the power of 0. 3 to the power of 0. So any number to the power of 0 is 1, right? Any number to the power of 0 is 1. So log base 7 of 5x minus 3. So now, in order to find 5x minus 3, this expression is going to be equal to 7 to the power of 1. Alright, so 7 to the power of 1 is going to be equal to 5x minus 3. 7 to the power of 1 is 5x minus 3. Alright, so 5x minus 3 is going to be 7 to the power of 1 is 7. And then I can add 3 to both sides because I want to get x here. Let me leave a space. Okay, so I want to get x here. First of all, I need to get rid of negative 3, and then I'm going to get rid of 5. So first I'm going to add 3 to both sides. Then I will have 5x on the left because negative 3 plus 3 is going to be 0. 5x is going to be 7 plus 3, 10. And now I can divide both sides by 5. So let's divide both sides by 5. So 5 and 5 is going to be cancelled out on the left side. So on the left I have only x, so 10 divided by 5 is going to be equal to 2. So this is going to be the solution to this equation. So x is going to be 2 here. Okay, so this is a similar example, and it looks a little bit complicated, but we are using the same idea, we are using the same rule. So this expression, whatever you see here, this expression, that's going to be equal to 1 over 3 to the power of -1. So log base 5 of, I'm just going to copy this, okay? So log base 5 of 10x plus 25 is equal to 1 over 3 to the power of -1. Okay, so now we need to remember when we have a over b to the power of -x, so we take the reciprocal of this fraction, so we make it b over a, and then we make it positive. -x will become a positive number, so it's going to be just x, okay, positive x. So here we are using the same idea. So 1 over 3 to the power of -1, just take the reciprocal, it's going to be 3 over 1, and -1 is going to be 1. So 3 over 1 is 3, and 3 to the power of 1 is also 3. So on the right hand side I have 3. So on the left I have log base 5 of 10x plus 25. 10x plus 25. Alright, so 5 to the power of 3, 10x plus 25 is just going to be equal to 5 to the power of 3. Because this expression right over here is going to be this base to the power of this number. And 5 to the power of 3 is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So 10x plus 25 is 125. Alright. So now I'm going to be subtracting 25 from both sides, okay, first. And then I'm going to divide both sides by 10 because I want to get x. I have to get rid of positive 25 first, and then I'm going to get rid of 10. So let's subtract 25 from both sides. Then I will have 10x, because this is going to be 0. 10x is equal to 100, right? 125 minus 25 will be 100. And then I can divide both sides by 10. Let's divide both sides by 10. So this 10 and this 10 will be cancelled out. So as an answer, x is going to be 100 divided by 10 will be 10. X is going to be 10. So the solution to this equation will be 10. Let's do another similar example. So we have log base 2 of 2 plus log base 3 of 5x minus 1 is equal to 2. It looks complicated, but believe me, it's not really a difficult question. So let's start with this. 2 to the power of 2 is just going to be equal to, let me write it down in the right hand side, 2 to the power of 2 is going to be equal to, so whatever this expression is, so that is 2 plus log base 3 of 5x minus 1. And so we have 2 plus log base 3 of 5x minus 1. 2 to the power of 2 is 4. We multiply 2 by itself twice, so 2 squared is going to be 4. Okay, now I need the value of this expression, and I have 2 plus log base 3 of 5x minus 1 is equal to 4. So this expression right over here, this one right over here, that's going to be 2, right? Because 2 plus what is 4? So that is 2, right? This is going to be 2. So log base 3 of 5x minus 1 is equal to 2. And then we're going to do the same thing. We're going to take 3 to the power of 2. So that's going to be 5x minus 1. 5x minus 1 is going to be equal to 3 to the power of 2. So that means 5x minus 1 is going to be equal to 3 to the power of 2. 3 squared is 9. And now I have to find x. That means I need to leave x alone on the left side. That means I'm going to get rid of -1 and 5. So first let's add 1 to both sides. So 5x is going to be 9 plus 1, which is 10. Here this is going to be 0. And now I can divide both sides by 2. I'm sorry. I can divide both sides by 5 to get x. So 10 divided by 5 will be 2, or 5 times what is 10? So x is just going to be 2. So this is the answer to this equation. Okay? So x is going to be 2. And then now I'm going to write the last example here. Alright, now let's find the value of x in this equation. So take a look at this example first, give it a try, and so let's start. So we're doing the same thing. 11 to the power of 0 will be equal to this expression. So let's write, actually let's do it this way. I'm gonna write log base 7 of log base 2 of 13x minus 2. So 11 to the power of 0, right? 11 to the power of 0. 11 to the power of 0 is 1. And so that's going to be log base 7 of log base 2 of 13x minus 2. And now I have to find this expression, the value of this expression. So that's going to be log base 2 of 13x minus 2. That's going to be 7 to the power of 1. And 7 to the power of 1 is 7. 7 to the power of 1 is 7. Or let me write 7 to the power of 1. So log base 2 of 13x minus 2 is just going to be 7. So 13x minus 2 is going to be 2 to the power of 7. So 2 to the power of 7 will be in this expression. So that's 13x minus 2. So let's find 2 to the power of 7. So we multiply 2 by itself 7 times. 1, 2, 3, 4, 5, 6, and 7. Alright, so 2 to the power of 2 times 2 is 4, and 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, and 64 times 2 is 128. So this is going to be 128. And I add 2 to both sides to get the 13x. So let's add 2 to both sides. So 13x is going to be equal to 130, because negative 2 plus 2 is going to be 0, and 128 plus 2 is 130. So if we just divide 130 by 13, 130 by 13, we are going to get the answer. So x is going to be 10. Alright, so the solution to this equation is going to be equal to 10. So x, the value of x here is 10.